Hey everybody, and welcome back to another lesson in Algebra 1. Today's lesson is about Unit 3, Lesson 2, and we're going to be looking at functions in a variety of contexts. We do want to go in and identify what an independent and dependent variable are, and then, I put a sloth over here that's like science and math, best friends forever. That's because one of the things that you see in common is this whole independent and dependent variables. Another part that you need to know today is that you need to realize that a function is a rule, and if it's a rule, we can calculate outputs. And then we're going to address graphing some data, so a little bit of review for that. Okay, so let's go ahead and start writing down some information. Okay, so remember from science, we have an independent variable, and this is the variable that the scientist manipulates. Okay, and the independent variable, we're going to graph it down here on the x-axis. Okay, so this is where the independent goes. Okay, now the independent variable, we can call it some mathy kinds of names, and we've got three of those right here. So we can call it the input, we can call it the domain, and we can call it the x value. So we can go ahead and just put these as little bullets down here. This is going to be my input. This is going to be my domain. Or we can call this my x value. Okay, so often what you'll see for your independent variable, a common example is going to be, let's see, we'll do common example, is going to be time. Okay, time is a common one. And so you might see that in terms of days or hours or years. It's a common example that ends up being graphed onto the x-axis. Alrighty, so let's go ahead and look at our dependent variable. Oops. So my dependent variable, this is going to be, when we're thinking about it, this is going to be the outcome of my experiment. This is what's happening. If we're talking about in science, this is the outcome. And we would end up graphing this over here on the y-axis. Okay, so this would be my dependent variable. And it's got some mathy names too. And so one of those is the output. So we can write that here. Another one is the range. We can write that here. And then another one is the y value. Okay, so that would go on your y-axis. And so an example of that might be, in these kinds of problems, maybe it's going to be something like earnings. This is a common example. Maybe if you work a certain number of hours, you get paid a certain amount of money. So the independent variable would be how many hours you work, because you're in control of that, right? So you would be like, I'm working full time, or I'm only working 5 hours a week, whatever it is, that is your input. The earnings happen because of how much you worked. So that is why it is the dependent variable. All right, let's look at this. We've got an example of some drawings. So let's say we have an artist that is going to sell their drawings for $10 each, and they charge a flat dollar fee for supplies. And so we want to know what the independent and dependent variables are. Well, let's start to break this down. Let's think about what they're in control of, or what is dependent on what. Okay, so you have two things. You could have, here, let's go ahead and write this out. We got our independent variable and that we could abbreviate IV. And then we have our dependent variable. Okay, so think about it like this. Let's say that this artist goes to a sale and they want to make like $500. Well, they can't wish that $500 into being. They have to have plenty of drawings to sell in order to make that $500. So our independent variable is going to be our number of drawings. Okay? If they want to make more money, they've got to make more drawings. It's that simple. And so, however many drawings that they have there and available to sell, that will determine their earnings. So, their earnings is their dependent variable. They can't earn more than what they have there to sell at this event or wherever they are. So that's why that is the dependent variable. Okay, so this next question, it's asking about it's asking us to write an equation to represent how much money they make. So they told us that y is how much money, and then the number of drawings is going to be x. I'm going to go ahead and write that down again because part of math is being super organized in your thinking. And so we want to make sure that you're very organized with things. So this is called a let statement. So what we're going to do is I'm just going to define what my x is and what my y is. So my x, it told us what it is. It's going to be the number of drawings. Okay. The reason that I'm going to write this down is because as you go through and you solve word problems, it's very easy to forget what your X and your Y stand for. Even if it says it in the problem, it's very easy to forget what it stands for. And then before you know it, you're just doing kind of stuff willy-nilly, not really knowing why you're picking, this number or that number. Okay, so we did also see that the how much money is going to be the y, so that's going to be my earnings. So when I go through and I calculate this, my x is going to be my number of drawings, my y is going to be my earnings. Notice that there's earnings here on the y, and then, down there on the x, I have number of drawings. I already labeled it for you. We need to write an equation. So let's go back up here and let's think about what each thing means. Anytime you see something like a flat fee in relation to an equation, that is going to mean that it is your y-intercept. Okay, it's something that it doesn't matter how many of those you sell or do or whatever, it's going to be a $5 flat fee regardless. They're going to be selling their drawings for $10 each. Okay, so we know it's $10 each. And I said my number of drawings, I said it over here, that is my X. So I'm going to put 10X because if I sold 2 drawings, it would be $10 for each of them. And so I do 2 times 10. Okay, so it makes sense those two go together. Now, if we add together that plus the flat fee, that's going to give me my Y. That's going to give me my, the total number of earnings. So that's what this is. This is my equation. Once we know this equation, we can do some calculations. Okay, so it tells us to complete the data table based on selling drawings. And so we have numbers sold. That's going to be my X over here. And my earnings is going to be Y. And I gave you a space for scratch work. I'm going to go ahead and write my equation right here because I want to just make it nice and neat and easy for me to keep looking at things and knowing exactly what it is that I'm looking for and what I need. Okay, so I'm going to start doing some math. Let's see, my X goes right here. So all of these numbers, I'm just going to put in that spot. So if I have 10 times 1 drawing plus 5. Okay, well 10 times 1 is 10 plus 5 is 15. That means my earnings is 15 if I sell 1 drawing. Okay, I'm going to do the same thing for the next part. So again, it's going to be 10, and then my X is 2. Okay, so I can drop my 2 in here. That's selling 2 drawings plus my flat fee. 10 times 2 is 20 plus 5 is 25. Then I'm going to do it again. I have 10 times my number of drawings, which is 3. I'm going to drop my 3 in here, plus 5. 10 times 3 is 30, plus 5 is 35. And then we're going to do it again for 4 drawings. 10 times 4 drawings, because that's what my x value is for this case, 10 times 4 plus 5. So that's 45. I don't know why my thing is all of a sudden circling, like making those red. I don't know what I did there to make that happen. Okay, we're going to do it for this last one. We got 10 times 5 plus 5. Oh, you know what? I want to point something out before I write down that answer. Something you may have already noticed. You notice, look, this was a plus 10, and this was a plus 10. This is the slope of my equation, okay? Every time it was going up 10, because for every additional drawing, I was getting to make another $10. So we could make this prediction here that this is going to be 55. That seems like a reasonable prediction based on everything we've done. And so let's just check it over here. 10 times 5 is 50, plus 5 is 55. So our prediction worked out. So good for us. Okay, now we're going to go and graph this. I have no idea what this thing is doing with these selecting of everything. Okay, so my first number that I'm going to graph is this 15. And so that's if we do one drawing. So we got 15. 2 drawings is 25. So keep in mind when I am graphing this, let me go ahead and I'm just going to erase some of this here. Keep in mind when I am graphing this, I'm just pulling my points from this. Okay, so let's see. Let me just grab a highlighter here that we haven't used. So I'm just grabbing 1 and 15. Okay, and then 2 and 25. Okay, 3 and 35. Whoops, got the wrong thing. I always pick that graphite one eventually once every class, I swear. Okay, and then the next one is going to be 45, and the next one's going to be 55. And so we can draw our line, and it's not that great, but there you go. That's me freehanding a line. I do want to take a second to point out something of interest here, which is this guy. Look, it did not cross the y-axis down at 0. Well, why is that? That's because there was a flat fee of $5. Okay, that was for the materials. No matter how many drawings there was a flat fee. And so the materials cost something to get started. And so that's why we've got, this y-intercept of a plus 5. Our equation told us it would be that way. Anyway, until next time, guys. Bye.